हेलो एवरीवन, वेलकम टू माय यूट्यूब चैनल। लास्ट वीडियो में हमने एक्सरसाइज 13.1 के क्वेश्चन नंबर 1 से लेकर 9 तक सॉल्व किया है। इस वीडियो में हम क्वेश्चन नंबर 10 से सॉल्व करेंगे। सो आइए देखते हैं क्वेश्चन नंबर 10 में क्या गिवन है। ए ब्लैक एंड रेड डाइस आर रोल्ड, फाइंड द कंडीशनल प्रोबेबिलिटी ऑफ ऑब्टेनिंग सम ग्रेटर देन 9 गिवन दैट द ब्लैक डाई रिजल्टेड इन 5। एंड बी में गिवन है फाइंड द कंडीशनल प्रोबेबिलिटी ऑफ ऑब्टेनिंग द सम 8 गिवन दैट द रेड डाई रिजल्टेड इन ए नंबर लेस देन 4। कंडीशनल प्रोबेबिलिटी, यहाँ हमें कंडीशनल प्रोबेबिलिटी फाइंड करना है। ठीक है, कंडीशनल प्रोबेबिलिटी का कॉन्सेप्ट और उसका डेफिनेशन मैंने लास्ट वीडियो में डिस्कस किया है। अगर आपको पता नहीं कंडीशनल प्रोबेबिलिटी क्या है तो आप डिस्क्रिप्शन में फर्स्ट वीडियो का लिंक दे दूंगा, आप वहाँ से देख लेना। तो आइए ये क्वेश्चन सॉल्व करते हैं। क्वेश्चन नंबर 10A, वी हैव गिवन 2 डाइस, वन इज ब्लैक एंड अनदर इज रेड। तो फर्स्ट let B denotes black die and R denotes red die. Now we have to write the sample space. Then the sample space is what will be the sample space? The first black die shows 1, B1, and red die shows also 1. So B1 R1. Another one is black dice shows 1, red die shows 2, B2 R2, B3 B1 R3, B1 R4. Means black die shows 1, red die 4 shows. Red die shows 4. Then B1 R5, then B1 R6. Again, the black die shows 2, red die shows 1, B2 R1, B2 R2, black die shows 3, red die shows, black die shows 2, red die shows 3, 2 3, 2 4, 2 4, then B2 5, then 2 6 R6, like this. Again, black die shows 3, red die shows 1, black die shows 3, red die shows 2, B3 R3, B3 R4, B3 R5, B3 R6, and B4 R1, B4 R2. So these are the sample space for black die and roll die. If you roll 2 die, black and red, then this will be the sample space. We have 36 outcome. Now see what is given in the, it is given that find the conditional probability of obtaining a sum greater than 9. One event is sum greater than 9 and another event is the black die resulted in a 5. Black die resulted in 9. So we have given 2 events. One event is, so let A denote the event, right? Let A denotes the event that the sum is greater than 9. Sum is greater than 9. Then what will be the outcome for this event A? Sum is greater than 9. When these two sum will be greater than 9. See 4 and 5, 4 plus 5 9, but we need greater than 9. So 4 6, 4 plus 6 10. So it will be B4 R6. This will be one outcome. Another one is 5 4, it is 9, so we need greater than 9. That means 5 5, B5 R5, B5 R5, then B6 R6. 5 plus 6 11, it is greater than 9, so B5 R6. Then 6 4, B6 R4, then 6 5, B6 R5, then B6 R6. B6 R6. So these are the outcome for the event that sum is greater than 9. And another event is the black die shows, see it is given that the black die resulted in 5. Black die resulted in 5. So let again B denote the events. B denote the event that black die resulted in 5. Black die resulted in 5. So what will be the outcome for this B? See, black die 5. So it is B5 R1, B5 R2. This will be B black die. Always black die resulted in 5. B5 R1, B5 red die can 2, black 5, red die can take 3, then B5 R4, then B5 R5, then B5 R6. This will be the outcome. Now we have to find the conditional probability that sum is greater than 9 given the black die resulted in 5. That means we have to find the conditional probability of A given B. So for that we need A intersection B. So let's find what is in intersection of A and B. See this B5 R5 and B5 R5 is in common, then B5 R6, B5 R6. These two are in common and nothing else is there. So the intersection will be B5 R5 and B5 R6. These two will be in intersection. So what is the probability of A intersection B? Probability of A intersection B is, how many outcomes is there? Only 2, 1 and 2. So 2 divided by total outcomes is, in the sample space it is 36. So this will be 2 by 36. Now we need probability of B also. Again probability of B will be how much? 1, 2, 3, 4, 5, 6. So total favorable number of outcomes is there. Favorable number of outcome is 6 and the total sample space is 36. So this is 6 by 36. That means 6 1s are 6, 6 6 are 36. This will be 1 by 6 and this will be 2 1s are 2, 2 18s are 36. So probability of A intersection B is 1 by 18 and probability of B is 1 by 6. Now we have to find probability of A given B. And probability of A given B, we know probability of A intersection B divided by probability of B. Now we have probability of A intersection B is 1 by 18. So it will be 1 by 18 and probability of B is 1 by 6. So the final answer will be 1 by 18 into 6 by 1. 6 1s are 6, 6 3s is 18. So the answer will be 1 by 3. So probability of A given B is 1 by 3. Now see what is given in B. In B it is given that find the conditional probability of obtaining the sum is 8. The one event is sum is 8 given that the red die resulted in number less than 4. So we have two events, and one is the sum is 8 and another event is the red die resulted in a number less than 4. So first let's write the outcome for the two events. So for 2, write let E denote the event of obtaining a sum 8. So what will be the outcome for this event E? The sum is 8. Now check the sample space when the sum will be 8. See here 2 plus 6 the sum is 8, then 3 5 sum is 8, then 4 4 sum is 8, 5 3 the sum is 8, 6 2 sum is 8, 1 2 3 4 5. This 5 will be there. So write only these 5 outcomes. So B2 R6, B3 R5, then B4 R4, then B5 R3, then B6 R2. Only in these outcomes we have the sum is 8. Again, let F denote the event. F denote the event of getting a number, less than 4 on red die. So what will be the outcome for this event? It is a number less than 4 on red die. Now check on the sample. So now check on the sample space which outcome have red die less than 4. So this will come, this and this. In this event the red die shows 5, so it will not come. So this and question it is given that red die less than 4, so ये भी नहीं आएगा, 4 भी नहीं आएगा, ठीक है. We need less than 4, so up to 3. Then this and this one and this one and this one. Write only those outcomes who have red die shows less than 4. So now let me write the outcomes. This will be B1 R1, B1 R2, then B1 R3, B1 R4 नहीं होगा, then B2 R1, B2 R2, then B3 R3, then B3 R1, B3 R2, B3 R3, then B4 R1, B4 R2, B4 R3, then B5 R1, B5 R2, B5 R3, then B6 R1, B6 R2 and B6 R3. These will be the favorable outcomes for F. Now we have to find the conditional probability of E given F. We have to find the conditional probability of E given F. So for that we need to find the probability of E intersection F. So E intersection F. So in E intersection F, what will be the outcomes? Check. B2 R6. In F we have R die shows, all the R die shows less than 4. So this will not come, this will not come, this will not come, only B5 R3. B5 R3, see B5 R3 is there, B5 R3 and B6 R2. So B6 R2 is there, only these two will come. So this will be B5 R3 and B6 R2, only these two will come. So what will be the probability of E intersection F? Probability of E intersection F will be, there is only 2 favorable outcomes, so 2 and total number of outcome is 36, so 2 by 36. And we also need probability of F also, and probability of F is, how many outcomes are there in F? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Total 18. And sample space is 36, so 18 by 36. So now you can find the probability of E given F as probability of E intersection F divided by probability of F. Now probability of E intersection F is 2 by 36 and F is 18 by 36. So the final answer will be 2 by 36 into 36 by 18. 36 cancel, 2 ones are 2, 2 nines are 18. The final answer will be 1 by 9. Now see what is given in question number 11. A fair die is rolled. Consider the event E equals to 1, 3, 5, F equals to 2, 3 and G equals to this. Now we have to find the conditional probability of E given F and F given E into E given G and G given E, and we have to find this conditional probability also. So let's solve this one by one. First write what are the given conditions. Given E equals to 1, 3, 5 and F equals to 2, 3 and G equal 2, 3, 4, 5. These are the given. Now we have to write the sample space. The question it is given that a die is rolled, a fair die is rolled. So sample space will be 1, 2, 3, 4, 5 and 6. These are the sample space. Now in 1 we have to find probability of E given F. So to find this probability of E given F, we know probability of E given F is probability of E intersection F divided by probability of F. Now first we have to find the probability of E intersection F. So what is in the intersection of E and F? So E intersection F is equals to, see only 3 is there in intersection of E and F, so only 3. So probability of E intersection F, probability of E intersection F is only one outcome is there, so 1 by, and total is 6, so 1 by 6. And what is probability of F? The probability of F equals to, the 2 outcome is there, so 2 divided by, and total is 6, so 2 by 6. So put here probability of E intersection F is 1 by 6 and probability of F is 2 by 6. So 6 cancel, the answer will be 1 by 2. Now in 2 we have to find probability of F given E. Same probability of E intersection F divided by probability of now given E, so it will be probability of E. So now probability of E intersection F is 1 by 6 and probability of E will be 3 outcome is there, so 3 probability of E will be 3 by 6, so it is 3 by 6. 6 cancel, the answer will be 1 by 3. Now in 2 we have to find probability of E given G and probability of G given E. So for E given G, we know it will be probability of E intersection G divided by probability of G. And what is probability of E intersection G? First we have to find E, what is in the intersection of E and G. So E intersection G will be, check, this 3 and 3 are in intersection, 5 and 5, so 3 and 5. E intersection G are 3, 5. So probability of E intersection G will be, E intersection G will be 2 element is there, so 2 divided by 6. And probability of G will be, in G 4 outcome is there, so it will be 4 by 6. So put it here, E intersection G is 2 by 6 divided by probability of G is 4 by 6. So 6 cancel, this will be 2 by 4, which is 1 by 2. And again probability of G given E. G given E is again probability of G intersection E divided by probability of E. G intersection E and E intersection G both are same. So this is probability of G intersection E is 2 by 6, since both are same. And we have to find probability of E. Probability of E we have to find here, probability of E is 3 by 6. Probability of E is 3 by 6. So 6 cancel, the answer will be 2 by 3. Now in 3 we have to find probability of E union F given G and E intersection F given G. Now to find probability of E union F given G, we have to find the union of E and F. So first find what is in the union of E and F. So in question it is given that E is 1, 3, 5 and F is 2, 3. So E union F will be 1, 2, 3 and 5. Only this 4 will be there. 1, 2, 3 and 5. E union F. Now in the original formula of conditional probability, we have probability of A given B is probability of A intersection B divided by probability of B. Now see here, in place of A we have E union F. So it will be probability of this. In place of A we have E union F. E union F and then intersection of B. So in B we have G. Intersection of G divided by probability of this G. So now we have to find the intersection of E union F and G. Now what is given in the G? G has 2, 3, 4 and 5. So their intersection will be E union F. Intersection G will be see 2, 3 and 5. See 2, 3 and 5. So 2, 3 and 5. Only these three will be. Now we have to find the probability of this. So probability of this E union F intersection G will be, how many outcomes are there? 3. 1, 2, 3. So 3 and total is 6. So 3 by 6. And we need probability of G. Probability of G is how many elements are there? 1, 2, 3, 4. So 4 by 6. So we can find here this probability of this is 3 by 6. So this will be 3 by 6 and probability of G is 4 by 6. So this is 4 by 6. Now 6, 6 cancel. The answer is 3 by 4. Now see here, we have to find probability of E intersection F given G. So for that we need to find E intersection F. So what are the intersection of E and F? E intersection F will be, see, in intersection of E and F only 3 is there. 3 is there, 3 is there. So the intersection only 3. And we have to find probability of E intersection F given G. So the formula will be probability of E intersection F, this intersection G divided by probability of G. Now probability of E intersection F is, probability of E intersection F is, we got 3, only 3. And now we have to find this E intersection F with intersection with G. So E intersection F intersection with G. Now check what is this. Only 3. Say 3 and this 3 are in intersection. So this will be also 3. Now what will be the probability of this? The probability of this will be probability of this event E intersection F intersection G will be 1 by 6 since one outcome is there, and probability of G is, we found before, it is 4 by 6. 4 by 6. Probability of G is 4 by 6 here. We found here. So this is 1 by 6 divided by 4 by 6. So the answer will be 1 by 4. So 6, 6 cancel. Now let's solve question number. In question 12, it is given that assume that each born child is equally likely to be boy or girl. So if a family has 2 children, what is the conditional probability that both the girls are given that the youngest is a girl and into at least one is girl? So first let's write what are the sample space. So let B denotes the boy, B denote boy, and G denote girl, then the sample space is S will be either both girl or both boy, or either first one is girl, second one is boy, or first one is boy, second one is girl. These four will be there. Only these four outcomes is possible. Now see the question. In question it is given that we have to find the conditional probability that both are girls, given that the youngest is a girl. So for that we have to define the two events. The first event is, let E denote the event that both are girls. So what will be the outcome for this event? GG. And what will be the probability of this? Probability of this event E will be, only one outcome is there, and the total outcome is 1, 2, 3, 4. So 1 by 4. Now second event is F. Let F denote the youngest. F denote the event. The youngest is a girl. So what will be the outcome for this event? So this will be GG, and it says the youngest is a girl, so this will come BG, boy, and then girl. Girl is youngest. So only these two outcome will be there. Now what is the probability of this F? Probability of this F is, two outcome is there, 2, and total is 4. So 2 by 4. This is 1 by 2. Now we have to find that the conditional probability of E given F. So find probability of E given F is probability of E intersection F divided by probability of F. So we need to find the probability of E intersection F. So first we have to find what is in the intersection of E and F. Check. The intersection of E and F is only this, GG, GG. So G, girl, girl. So what is the probability? Probability of E intersection F is again 1 by 4. So this probability is be 1 by 4, and probability of F is 1 by 2. So this will be 1 by 4 into 2 by 1, 2 1s are 2, 2 2s are 4. That means it is 1 by 2. Next, what is given? We have to find that the conditional probability that both are girls, given that at least one is a girl. At least one is a girl. So we have to find this event also. So write for 2, let H denote the event. H denote the event. H denote the event that at least one is girl. So what will be the outcome of this event? H, at least one. So GG, boy, girl, girl, boy. These three will be in the outcomes of H. So now we have to find the probability of E given H, and the formula will be probability of E intersection F divided E intersection H divided by probability of H. So we have to find the probability of H and their intersection. So probability of H we can find from here. Probability of H is, how many outcomes are there? 3. So 3, total is 4. So this is 3 by 4. And now we have to find E intersection H. So check what is in the intersection of E and H. E has GG and H has also GG. So their intersection will be only in GG. So probability will be E intersection H. Probability of E intersection H will be 1 by 4. So this will be 1 by 4, and probability of H is 3 by 4. So the final answer will be 4, 4 cancel. This is 1 by 3. Now we will solve question number 13. So before solving the question number 13, please subscribe my channel and like the video. Now see, in question number 13, it is given that an instructor has question bank consisting of 300 easy true false question and 200 difficult true false question. and 500 easy multiple choice question and 400 difficult multiple choice question. So we have one is true false question, true false, and another one is MCQ questions. So in true false question we have 300 easy question and 200 difficult question, 200 difficult, and in MCQ 500 easy and 400 difficult question. Now if a question is selected at random from the question bank, if a question is selected, then what is the probability that it will be an easy given that it is a multiple choice question? So we have an event that it is an easy question and another event is it is multiple choice questions. So first write solution. There are, see how many true false question are there, 300 and 200, that means there are 500 true false question. And how many MCQ question? 500 plus 400 is 900 and 900 MCQs, multiple choice question. And how many easy questions are there? Also this 300 and this 500, 800 easy questions are there, also 800 easy questions. And how many difficult? This 200 and 400, this and 600 difficult questions. And how many outcomes is in the sample space? Total is this 300, 200, 500, this 500, 1000 and this 400, total is 1400. So total outcomes in the sample space, total outcome in the sample space is equals to 1400. So now let write, let E denotes the event, E denote the event that we have to find. See, selected question is easy, so let E denote the event that the question is easy, the question is easy. So what will be the probability of this E? Probability of E will be, how many easy questions are there? 800. See, 800 easy question, so 800 and total outcome is 1400, so 800 divided by 1400, so this will be 0 0 0 0, 2 4s are 8, 2 7s are 14, this is 4 by 7. And F denote the event, F denote the event given that it is a multiple choice question. F denote the event that the question is MCQ, that the question is MCQ. So what will be the probability of F? How many MCQ question are there? 900, so it will be 900 divided by total is 1400, so it will be 9 by 14, 9 by 14. Now we have to find the probability that it is easy given it is from MCQ, probability of E given F. So it will be probability of E intersection F divided by probability of F. Now we have to find the probability of E intersection F, and probability of F is 9 by 14. So probability of E intersection F means probability of E intersection F. E intersection F means the question is easy and intersection means and. E denotes, see I have written here, E denotes the event that the question is easy, and intersection means S, and easy and MCQ. Easy and MCQ, how many questions are there in easy and MCQ? See 500 MCQ question are easy, so it will be 500 divided by 1400. So it will be 5 by 14. So right here E intersection F, probability of E intersection F is 5 by 14 and probability of F is 9 by 14. So 14 cancel, the final answer is 5 by 9. So the conditional probability is 5 by 9. Now see question number 14. In question number 14 it is given that two numbers appearing on throwing two dice are different. It is given the two numbers appearing on throwing two dice are different. Now we have to find the probability of event. The sum of number on the die is 4. So we have two event. One is the sum of the number on the die is 4 and another event is the two dice are different. The numbers appearing on two dice are different. So first write what are the sample space. Two dice are throwing, so the sample space will be S will be this 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 like this, 2, 1, 2, 2, 2, 3 like this, 2, 6, then 3, 1, 3, 2 like this, 3, 6, 4, 1, 4, 2. Please write these events. Then 4, 6, 5, 1, 5, 2 like this, 5, 3, 5, 4. Please write these outcomes. Then 5, 6 and 6, 1, 6, 2 and 6, 6. So how many outcomes are there? Total 36 outcomes. Okay. Now we have to find, let E denotes the event. Let E denotes the event that the sum of the number is 4. Sum of the numbers on the die is 4. So what will be the outcome for this event E? The sum is 4, so 1 plus 3 is 4. This 1 plus 3 will be there. Then 2 plus 2 is 4, so 2 is there. Then 1, 3 is there. So only these three outcome will be there. And another event is F denote the event that the two numbers appearing on the die are different. Appearing on the die are different. Then what will be the outcome? See, in the sample space the same numbers are these 1, 1, 2, 2, there 3, 3, 4, 4, 5, 5, 6, 6. Only these 6 will be left and all the other outcome will be there. So F will be this 1, 2. Since we need the outcomes are in the different 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, then 2, 1, then 2, 3, 2, 4, 2, 5, 2, 6, then 3, 1, 3, 2, 3, 4, then 3, 5, 3, 6. Like this you write 4, 1, 4, 2, then 4, 3, then 4, 5, and 4, 6. So this will be the outcome for the event F. Now we have to find probability of E given F. So we know probability of E given F is probability of E intersection F divided by probability of F. So for that we need to find the probability of E intersection F. So first we have to find what are in the intersection of E and F. So the intersection of E and F, what is in the E? E is, see, 1, 3 and 3, 1. These two are in the intersection of E and F. See, 1, 3 and this 3, 1. Since 2, 2 is not in F, so only these two will come. So the probability of E intersection F will be this 2 element is there, so 2 divided by 36, so 2 ones are 2, 2 18s are 36, so this is 1 by 18. Now probability of F is, in F how many elements are there? See, 1 2 3 4 5. In row 5 elements are there, and 1 2 3 4 5 6. In column 6, so 5 into 6, total 30 elements are there in F. So it is 30 by total sample space is 36, so 30 by 36. Now we can find probability of E intersection F is, we obtain 2 by 36, so it is 2 by 36, and probability of F is 30 by 36, so 30 by 36. Now 36 cancel, the final answer is 2 by 30, so 2 ones are 2, 2 15s are 30, so final answer is 1 by 15. Now let's solve question number 15. In 15 it is given that consider the experiment of throwing a die. If a multiple of 3 comes up, throw the die again, and if any other number comes, toss a coin. Find the conditional probability of event the coin shows a tail, given that at least one die shows a 3. So let's understand the question first. It is given that consider the experiment, throw a die. So a die is thrown. First a die is thrown. Now what happened? It says if multiple of 3 comes up, that means either 3 and 6. If 3 and 6 comes up, then what happens? Throw the die again. Again we throw the die. If this happens, then again we will throw the die. And if any other number comes, that means if 1, 2, 4 and 5, if this comes, then what he says? Toss a coin. Then toss a coin. If you toss a coin, then head and tail will occur, and here again 1 2 3 4 5 or 6, any one of these 6 will be occur. Now let's write the sample space, the sample space of the experiment. The sample space of the experiment. The sample space of the experiment is as, what will be the sample space? Now see, if 3 occur, first we throw a die. If 3 occur, then what will happen? If 3 occur, then we will again throw a die, and that may be 1, that may be 2, that may be 3, that may be 4, that may be 5, and that may be 6. Again if 6 occur, then again we throw a die, and along with this 6, again if you throw a die, then 1 may be occur, then 2 may be occur, then 3 may be occur, then 4 may be occur, then 5 may be occur, then 6 may be occur. Now if this occurs, suppose if 1 occur, then what happens? We will toss a coin. So if 1 occurs, either if you toss a coin, then head may occur or tail may occur. And if you throw a die and 2 occurs, then what will happen? Either next we will throw a coin, that may be head or that may be tail. Now if 4 occur, then we will toss a coin, that may be head, that may be tail. Now if 5 occurs, then we will toss a coin, that may be head, that may be tail. So these are the sample space of the experiment. Now see the question again. We have to find the conditional probability that the coin shows a tail. So let E be the event that coin shows a tail. So right here, let E be the event that coin shows a tail. So what will be the outcome for this event? See, coin shows a tail, coin shows a tail, coin shows a tail. This will be the outcome. 1, t, 2, t, then 4, t, then 5, t. This will be the outcome. And then another event is at least one die shows a 3. Again, let F denote the event at least one die shows 3. So what will be the outcome for this event F? Check the sample space. At least one die shows 3. That means this will be there, this, and this, and this also. So 3, 1, 3, 2, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, and 6, 3. These will be the outcomes. So now we have to find E intersection F. Since we need to find the conditional probability of E given F, so we have to find E intersection F. E intersection F is, see, nothing is in the intersection, so it is phi. So now we have to find probability of E given F. So E given F is probability of E intersection F divided by probability of F. So E intersection F is 0 and probability of F is 1, 2, 3, 4, 5, 6, 7. So this is 7 by total is, how many elements are there in sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20. Probability of F is 7 by this 20. So 0 by this is answer is 0. Now see question number 16. In question number 16 it is given that probability of A is 1 by 2 and probability of B is 0. Now I have to find probability of A given B. Now probability of A given B, we know probability of A intersection B divided by probability of B. Now see, it is given in the question probability of B is 0. I have said that if something divided by 0, this is not defined. So probability of A intersection B, this will be a positive number, and this is probability of B is 0. So any positive number divided by 0, this is not defined. So option C is correct. Now see in question number 17, it is given that A and B are events such that probability of A given B and B given A are same. Then which option is correct? So it is given that probability of A given B, which is same as probability of B given A. Probability of B given A. Now we know probability of A given B is probability of A intersection B divided by probability of B, and B given A is probability of B intersection A divided by, this is A is given, so probability of A. Now from here, see, probability of A intersection B and B intersection A are same, so we can cancel both these. So now 1 by probability of B equals to 1 by probability of A. So from here we can write probability of A equals to probability of B. Probability of A equals to probability of B. See which option is correct. Option D is correct. So please like, comment and subscribe my channel. Thank you.